I'm CHEM Abuso.
And I'm Cherry Cooley.
So now we're going to show you how to make a lava lamp.
First thing to do, we're going to put 2 tablespoons of baking soda. Second, we will going to put cooking oil in the jar. Now, we're going to put vinegar in the food coloring. And lastly, we are pouring this mixture in a jar, then mix. The lava lamp experiment demonstrates the interaction between oil, water, and carbon dioxide gas produced by the reaction between baking soda and vinegar.
Good day, everyone. So we'll be having an experiment using corn, vinegar, a jar, a spoon, and a baking soda in order to make dancing corn.
Fill the container about halfway with water. Add a few tablespoons of baking soda to the water and stir until it dissolves. Wait until the water becomes clear. Drop a handful of corn kernels into the container with the baking soda solution. Slowly pour vinegar into the container, covering the corn kernels. The baking soda in the water acts as a base, and when vinegar is added, it reacts with the baking soda to produce carbon dioxide gas. The carbon dioxide gas forms bubbles around the corn kernels, causing them to float to the surface. As the gas is released, the corn kernels sink back down, and the process repeats, creating a dancing effect.
Good day everyone, so now I'll be discussing about the intensive properties. Intensive properties are those do not depend on the amount or size of the substance or object. They remain constant regardless of the quantity. Examples of intensive properties includes temperature, density, color, melting point, boiling, and refractive index. So for example, a cup full of milk. So I have here
Another example of an intensive property is the temperature. So I have here two cups of water, one filled with 100 ml of water and the other filled with 200 ml of water. As the creator, I know that the specific heat capacity of water is an extensive property and remains constant regardless of the amount of, of the amount of water present. To investigate this, To investigate this property, I decided to heat both cups of water applying the same amount of heat. I know that specific heat capacity is the amount of heat energy required to raise the temperature of a substance by a certain amount. As the creator of the experiment, I observed that even though the volume of water in the cup is different, the capacity heat of water remains the same. Therefore, the amount of heat energy required to raise the temperature of the water by the same amount is different for each cup. This experiment demonstrates that specific heat capacity is an extensive property because it is independent of the amount of the substance present.
This is the example of extensive property of the length and the differences between spoon and pencil. Length is an extensive property because it depends on the amount of material present. A longer spoon is typically contains more material than a shorter pencil. Thereby, it is increasing of length. Spoon and pencils can be easily observed and identified in real life through their distinctive shapes and functions. Spoons are commonly found in kitchen drawers or utensils holder typically made of metal, while pencils often seen in stationery stores, schools, and offices. It is made up of wood. Both items are specific purposes and are recognizable due to their unique characteristics.
I have two objects here, the rock and the wood. Rocks are significantly denser than wood, leading to a substantial difference in their weight. The density and composition of both rocks and wood play a crucial role in determining their respective weights.